All right, boys and girls, so welcome to your first quiz. If the 25-26 school year, this is going to be on Friday the 8th. That's your first one. This is the mother functions in Algebra 2, the parent functions, which all graphs that we study come from. All right, first one up is a graph f of x equals x, also known as y equals x. And I've got a grid here, but you can't see it on this particular board. Now, y equals x is something you should have studied around 7th grade. And we're going to feed it just three easy points. We're going to go from x is -1 to 0 to 1. And remember, the equation is literally y equals x. So if x is -1, guess what? Y is -1. And if x is 0, so is y. Same thing there. Three nice points. Now make sure that you clearly plot points. I don't accept slop. And I guess I'll give you an example of slop or crap. These are lines. Lines continue on forever. But I see a lot of kids just do that. I'm not taking that. I want my points. This is about precision and accuracy. Both things are important. Domain. So if you're in Algebra 2, you haven't heard domain talked about in probably a year. If you want to take some notes or whatever, domain is your input or your x values, okay? Then you got range, which is your output, which would be your y values. Now, there's more to this graph than just these 3 points. This particular graph is running left forever. It is moving left. It's eventually going to reach this idea of negative infinity. And it's also moving right, and it would eventually reach this idea of positive infinity. Now, we use what's called interval notation in Algebra 2, and you should have been exposed to this in Algebra 1. You may or may not have. But I primarily use interval notation. I'll also show set builders. I do a couple of these. Since we are running forever to the left, our domain is negative infinity, a comma, because we're everything between negative infinity all the way to the right, positive infinity. Now, our range here, the graph is also falling. Well, that marker's no bueno. But the graph is also falling. It's going down. It's falling to a y value of negative infinity. It's also going up to a y value of positive infinity. So for our range, negative infinity to infinity. Now, I said I'd mention something called set builder notation. Set builder notation uses your inequality symbols. And it's written kind of funny, but up here, for all values from negative to infinity, we would do a strong curly bracket, x bar, which is all values of x, such that, and we use this shorthand notation, x is an element of the real. I don't care if you do interval notation or set builder. I don't really have a preference. You pick yours. I like interval. For my range here, it'd be the same thing, but range is talking about your input, your y values. All values of y, such that y is an element of the real. And there's the first one. Each of these are worth 3 points. So all of that was 3 points. Okay? That was all 3 points. Let's move on to the second one here. I think there's 15 total. There's 5 or 6 bonuses in the beginning. And eventually we'll get all of them. We will. All right, the second one up. Graph f of x over y equals a constant. That's y equals a constant. Now, I know you have on your piece of paper, you've got a numbered out xy axis. And this isn't about this. Y equals a constant is a horizontal line. That's all it is. And it doesn't matter what x is. If x was -1, 0, 1, which is the 3 points I use quite often, y would just be a constant. That's all it would be. Just be some constant value. Now, constant means I'm something like 2, or I'm something like 3, or I'm something like 4. I am the same number forever. Forever. So I don't care where you put your horizontal line. What I do care is that you plot a point on it, and I'm going to plot that one as 0, comma, c. Now, I could also do something like this if I wanted to, and I would be perfectly okay with this. A kid could tell me -3, comma, constant. It doesn't matter. You pick either one of those. Pick what go along that general idea. I need to see that you have the y value recognized as a constant, and you need to understand that y equals a number is a horizontal line. Really big deal you understand that. The domain, this particular graph runs left and right forever, so it's another one of these negative infinity and positive infinity things. Its range is kind of interesting. Its range is simply that y is a constant, and it's done like this. So I've got brackets. Now, it's a good place to talk about the difference between parentheses and brackets. Parentheses are things that you cannot actually get to, that you cannot actually be. You cannot be infinity. A bracket is something that you can be. So, this one's worth talking about in Set Builder. This will be all values of y such that y is simply a constant. See, that's why I like interval notation so much better. The next one is x equals a constant. So if y equals a constant is horizontal, then x equals a constant must be vertical. So we pick some point on the x-axis and we draw a vertical line. Now, anywhere on that point, we have x as a constant, and here y would be 0 because it's on the x-axis. If you pick some other point, like maybe I'm down here at -3, we do constant -3. What does a table look like for x equals a constant? Well, a table for x equals a constant is just that all these x's are c's, and the y values could be anything. They could be like -10, 12, 40. Doesn't matter what they are, but the x is the thing that stays the same. That's what makes it vertical. Your domain here is a lot like the range of the previous one. Your domain here is that x is a constant, or all values of x, such that x equals a constant. Your range, and you need to learn how to read a graph. A lot of kids just do these things with rote memorization. They never quite get to understanding it. I push memorization. Memorization is a big deal because understanding happens after memorization. But this thing goes up forever and down forever. So in addition to memorizing, which maybe you do in the beginning, you need to focus on comprehension at some point in time. This is why I write these things. The range is going to be -infinity to positive infinity because it falls forever and it rises forever. Or if you like your set builder notation, you might be that kid. All values of y such that y is an element of the real. And there you go. 3 down, 12 to go. Now, most Algebra 2 teachers will call these parent functions. It's kind of lame, so I call them mother functions because it always gives me a chance to make a mistake. I might slip up in class one day. I might say something else. I've yet to do it. I've come close, not gonna lie. There's been times I've had the right group of kids and I've wanted to just throw that in there, and you know what I'm talking about. But I haven't done it yet because I still like to eat. Number 4, y equals x. Now, by the way, I've said something here I haven't mentioned it is that f of x, that is always a y. It is just fancy for y. So this is y is the absolute value of x. So let's go to our table here. Let's let x be these 3 points, which we use often, -1, 0, and 1. And let's think about the absolute value of -1. And hopefully you remember that absolute value underline that V, by the way, is the distance from 0. That's what it is. A lot of people, they kind of dumb it down. They say it's always positive, and heck, I'll say that in class too, because the absolute value of something is always positive. It is. And the absolute value of a -1 is 1, because if we were to think about things on a number line, we would discover that this distance is 1 unit. Absolute value is a concept of distance. That's what makes it positive, because there's no such thing as negative distance. 0 is 0 units away from 0, and 1 is 1 unit away from 0. Now, over here, I underlined the V, absolute value with a V. The reason I did that is because after I plot my 3 points, there's 0, 0, 1, 1, negative 1, negative 1, I will see that if I connect those dots, I have a V. And we get into absolute value a great bit deal more. We start looking at it as a piecewise function. But that's the mom function. That's the graph. Value starts with a V. It's amazing to me every year how many kids just can't seem to get that in their head. It's like we're speaking a different language. Maybe we are. Maybe that's the problem. I don't know. All right, domain. This thing is running left forever. It is running right forever. Domain is going to be negative infinity to positive infinity. Now, the lowest value on this graph, the lowest y value, remember range is y values. The lowest y value is a 0, and I am putting my pencil there. I am touching that thing. That's a bracket. If you can touch that point, it is encapsulated with a bracket, not a parentheses. Now on either side of this V, we rise. We rise where? That's right, we rise to infinity. This particular one is worth talking about the set builder notation. We would have our curly braces. We would say all values of y such that, and then we have to use what's called inequalities, which I've discovered kids just can't stand. All values of y such that y is greater than or equal to 0 because it is 0 up. 0 up. All right, page 1 is done. Let's move on to page 2. I'm going to pause while I erase. Maybe that'll speed this video up a little. All right, we're back. We're on number 5. Graph f of x equals x squared. So x squared is huge. Like, it's not all that Algebra 2 is about, but it's 20% of it. Like, it's a big deal in Algebra 2. Quadratics. If we see an exponent of 2, we know that we have ourselves what's called a quadratic. Well, underline that U in quadratic. And they're big. Like, we need to know what this thing looks like. A lot of people, they just say it looks like the letter U. We call that a parabola, which I'll talk about in a second. So we're going to use 3 key points here. We should probably do another one just so you kind of get the gist of why it is the way it is. And I'll do that on this video. We're going to do -1, 0, and 1. And then I'm just going to throw down a 2 down here, okay? Now, what is y? Remember, this is y equals x squared. So if you take a -1 and you square it by multiplying it by itself, you get a positive 1. And if you do a 0 times a 0, you get a 0. And if you do a 1 times a 1, you get a 1. Now, if you take a 2 squared, hopefully you realize you get a 4. But again, the only 3 that matter, as far as I'm concerned, are these. If you only plot those 3 points, though, you would be very tempted to do what you just did on absolute value. But it's not, because you see you had 2, 4 as well, which is up here. It wouldn't make a very good V, would it? It just wouldn't. It's actually what we call a parabola in mathematics. And this is a parabola. You know, once upon a time, I didn't always used to write down the words, but I've discovered that kids just are horrible at spelling. I'm not sure when that happened. Probably around 15, 16, I started seeing a degradation in the ability to spell. Because I've called kids and be like, how do you think we spelled that word, when they couldn't realize how we graph things? And they weren't spelling it right. And you'll notice the lettering. The letters are important. All right, now this thing is domain and range. This graph will move to the left slowly forever, and it will move to the right slowly forever. So its domain is negative infinity to infinity. Now you'll notice I always start with a small value and go to the high value. Its low y value, which means I'm talking about range, is a 0. And that is nowhere near the right spot. Its small y value is a 0. And there it rises forever on either side of the parabola to a concept called infinity. Notice the bracket on the 0 and the infinity symbol is encapsulated in parentheses because I cannot touch infinity. I cannot take my pencil all the way to infinity. and put a dot there, because if I could put a dot there, I would just move up 1 unit and I'd be at infinity plus 1, which is still infinity. What a crazy concept. Number 6, graph f of x equals x to the 1/2. This is also written as y equals the square root of x. I like this one. A lot of kids get this one right. Now, the smallest thing you can take the square root of and be real is 0. You know, the square root of a -1 is imaginary. We haven't talked about that yet. So when I start my table, I can't start my table at -1, but I can start it at 0. And I'm also going to do 1, because I can take the square root of 1. And I'm going to do 4, because I can take the square root of 4. So think about this. Y equals root 0. That's a 0. Y equals the square root of 1 is 1, because 1 times 1 is 1. And then the square root of 4, I hope you know this, or I'm not sure why you're in Algebra 2, but the square root of 4 is 2. If you don't know the square root of 4 is 2, you're going to really struggle this year. I shouldn't laugh about it. It's kind of sad. But yeah, you're in trouble. Fix that problem. That's a you problem. That's not a me problem. That's not a math problem. That's a you problem. You grow and reflect. If you know you have a weakness, fix it. I do that every day. Seems like every day I find out something about myself I'm just not as good at as I think I am. Anyways, I plotted my point 0, 0. I plotted 1, 1, 4, 2. X is 4, Y is 2. And this is something that I have always heard of, and I think most people learn it this way, as the arm. That's how we learn it. It's the arm. It also kind of looks like an R. Remember, this was a square root. It does look a little bit like that R, but it's the arm, which I can't spell either. I wrote ARAM. Arm. All right, now the domain of this thing starts here where x is 0, right? So its domain is to start at 0 and then move right to infinity. We start at 0 and move right. Its range is extremely similar. We have a low y value of 0, and then we rise towards positive infinity. Now, if you're a set builder kid, and I almost made a mistake, notice how I put a parentheses on that? That was a solid dot, that's a bracket. If we're this kid that likes set builder notation, curly braces, all values of x such that x is greater than or equal to 0, or all values of y such that y is greater than or equal to 0. All right, let me pause and erase. And 1, and I'm going to add in a 2. So if I take a -1 and I cube it, that means I multiply it by itself 3 times, and I hope you remember that. So I do -1 times -1 times -1, and I get -1. If I do the same thing with a 0, I'll get a 0. If I do the same thing with a 1, I'll get a 1. And if I do 2 times 2 times 2, I'll get an 8. Now, these are the 3 that matter. Okay, the reason I did the 2, 8 is so you can see the shape of it. If you just plot those 3 points, you'd be very tempted to draw a straight line. That's just why I did 2, 8. 3, 4, 5, 6, 7, 8. That is the mother function y equals x cubed. It's not hard. I call it a snake. It's an x-axis, a y-axis snake. It stays real close to the y-axis. Domain, it is slowly moving left, and it is slowly moving right.
This morning, breakfast is at 8 o'clock at the elementary school if anybody's in the building. Thank you.
Yeah, I'm not going. I'm here working for y'all. Domain. We run left forever, we run right forever. We are also rising forever and falling forever. Notice I start off with the low negative values first, or the smaller values, negative infinity to infinity. Notice the parentheses because I cannot touch those numbers. I can't put my pencil there. All right, next up, the inverse of y equals x cubed. Y equals the cubic root of x. And it's going to look a lot like the last one. They actually have the same shape more or less, just one of them likes the x-axis. We'll do the same 3 points to some degree. -1, 0, and 1, and this time I'm going to put an 8. So if I take the cubic root of a -1, I know that's -1, because -1 times -1 times -1 is -1. If I take the cubic root of 0, I'd have a 0. If I take the cubic root of 1, I'd have a 1. And the cubic root of 8 is 2, because 2 times 2 times 2 is 8. You know, a lot of kids don't have number sense anymore, so they only know things because they push buttons in a calculator. You're in trouble. You're supposed to know things. Like, that's big. But the cubic root of 8 is a 2. So let's plot our points. We have 0, 0. We have -1, -1. We have 1, 1. And then we have 8, 2. X was 8, Y was 2. If you have a problem with graphing, please make sure you fix it. Notice it's got the same overall kind of shape as the last one, except it hugs the x-axis, not the y-axis. Nothing else is different about it. It runs left and right forever, so it still has a domain of -infinity to infinity. And it goes up and down forever, so it still has a range of -infinity to infinity. It's a good place to reintroduce set builder for these. If you like set builder, all values of x such that x is an element of the real, or for range, all values of y such that y is an element of the real, because remember, range is talking about your y values. All right, we only got, all right, bottom of the page, 2 to go. But this is the last one that you have to know for a while. It's called end behavior. End behavior is how a graph functions for large or small values of x. It has nothing to do with the origin. It has things to do that's happening way out here at positive infinity and back here at negative infinity. That's what it cares about. So it's called end behavior. Now, when you see f of x equals x to the even, I hope you're thinking about x squared, or maybe an x to the 4th. It doesn't matter. But x squared, remember, it looked like this, okay? Now, what I need to see from you is not a graph that has this stuff in the middle. It's called end behavior. It's not called middle behavior. It's not called origin behavior. It's called end behavior. But notice that x squared started high and it ended high. So for large values of x at positive infinity, the graph is going to infinity as well. And for small values of x at negative infinity, extremely small or extremely negative values of x, the graph is going to positive infinities. There's the graph. The in words part's going to throw some kids off. But in words, and we're going to do this as we graph from left to right. As x approaches negative infinity, the y value approaches infinity. That's half the end behavior. That's the left hand, okay? Also, as x approaches positive infinity, y approaches infinity. All right, next up is x to the odd. X to the odd, that would be something like x cubed. That's an example, by the way. Now, x cubed, if you just go back and look at your notes, looks something like that. But again, I don't want the middle behavior, I want the end behavior. And the end behavior for x cubed is to start low and finish high. Notice I have the xy axis. If you just do this, that's wrong. I want the xy axis. I'm very clear about that. In words, now as we move left towards negative infinity, the graph is falling, so y is also falling to negative infinity. Let me move this page a little bit for you. There we go. And as x runs right towards positive infinity, the graph rises. The y values rise towards positive infinity. 2 to go. Now I'm leaving those graphs up there for a reason, because this is negative x to the even. And if positive x to the even opens up, it ain't rocket science. Negative x to the even goes down, down. I am going to have to erase that one. So you just might have to look back at the notes you've taken. I was hoping I wouldn't have to erase it, but I do. Just not enough room. So anywho, negative x to the even, instead of being up, up, high, high, starts at stay low and ends at stay low. We had a good day in the middle, but we ain't worried about the middle. We're worried about the ends, right? The beginning and the end. In words, as x runs left towards negative infinity, the y values fall, or the range falls to negative infinity. And as x runs right towards positive infinity, turns also the output, the y values, are also falling again towards negative infinity. Negative x to the odd, remember positive x to the odd was low high. So negative x to the odd has got to be high low. It has been reflected vertically or over the x-axis. This one would be both. In words, as x runs left towards negative infinity, on this one the y values go up. And again, I mentioned something earlier. Read the graph, comprehend the graph. Okay? Don't memorize this stuff verbatim. Understand the graph. And as x approaches positive infinity, we can see the y values are falling to negative infinity. All right, everything out from here on out's bonus. It'd be awesome if everybody cared about the bonus stuff. You find that about 80% of your students do not care about bonus stuff because most of you are just trying to get that 60. It's really sad. It is what it is, though. Like, it's not a surprise to me. I wish I could give you all some motivation. But I don't know how to do that. I don't know how to get kids to want to learn something that they just don't want to learn. All right, this is a funny looking one. It's y equals a times b to the x. An example of this would be something like 2 times 3 to the x, which is not in the right spot. There we go. So there's some numbers. Now, we're not going to do 2 times 3 to the x, but it gives you an idea of how this thing would work, right? Like I can waste a minute or two here. But then we'll graph the mom function. 2 times 3 to the x. Okay, let's make a small table. Let's feed it a -1, a 0, and a 1. If I feed it a -1, I'd have 2 times 3 to the negative first power. Now, you guys don't know what a negative first power is. It flips the number. It's not 3, it's 1/3. So this becomes 2 times 1/3, which is 2/3. Now, a 0, 2 times 3 to the 0. Anything to the 0 power is 1. I usually use smiley faces, but anything to the 0 power is 1. So this becomes 2 times 1, which is 2. If I plug in a 1, I'd have 2 times 3 to the first. 3 to the first is 3. This is 2 times 3, which is 6. But the only reason I'm doing this is so I can give you an overall shape of what the graph looks like, okay? It has -1, 2/3, which would be about right there. It has 0, 2, which would be right there. It has 1, 6, which would be about right there. This is the exponential growth function. Okay? So now that I've wasted all that time on that, let's go back and do this one. I knew I forgot to do a little editing on here. I forgot to talk about something that these graphs have. I sure did. All right, so anyways, what do we want to feed this thing? We're going to feed this thing 2 key points. We're going to feed it a 1 and a 0. All right? So if I feed it a 0, I would have a times b to the 0. Again, by definition, anything to the 0 power is 1. That's a times a 1, which is just a. So if I feed it a 0, I get what's called an a back. Okay, weird, huh? If I feed it a 1, I have a times b to the first, which is anything to the first power itself, I get a times b back. Now, the reason I did that previous example was to give you an overall shape of the graph. But all exponential equations written in the form of y equals a times b to the x, they all contain the point 0a. Now I'm going to label this point. This point has to be labeled because your grid's got numbers and a is not on that grid. It will also contain the point 1ab. So I'm going to pick a point up here and label it 1ab. And then I'm going to follow that form that I had in the previous one. I put that 1ab in a bad spot. 1ab. You'll notice that I don't cross the x-axis as I draw. I flatline on it. That's because these things have what's called horizontal asymptotes. Exponential graphs have horizontal asymptotes, and it's right here. It is a horizontal line, which means it's written in the form of y equals a constant, and it happens to be y equals 0. We're going to talk about that. That needs to be added in on this little box over here. The domain is run left forever, run right forever. The domain is negative infinity to infinity. The range gets really close to a value of 0, but it doesn't actually touch it because it flatlines near it. And it rises to the right towards infinity. There I used parentheses. I didn't use a bracket because I actually never put a dot on the x-axis. Now, something that needs to be included in that box is the horizontal asymptote. And it is y equals 0. Do not just write 0. 0 gets you nothing. You have to say y equals. It has to be y equals. Last page. Nothing but bonuses from here on out. And there's 5 of them. All right, number 11. This is an exponential equation. It's y equals e to the x. E is a number given to us by this guy, Euler. It's pronounced Euler. He was French. But you'll notice his name starts with an E. And E is about 2.72. It's actually what you call an irrational number, kind of like pi. It's a decimal that never stops and never repeats. But it's a very special number in mathematics, and it's a very special number in the real world. Euler called it a natural number, and it is used in just about everything that's biological. Like it's literally a living number to some degree. It describes so many things. It's crazy how all this complex world that we live in can boil down to mathematics. Of course, we use mathematics to comprehend this world that we live in. But E is a very big deal in our understanding of how this world works. So anyways, we're going to graph Euler's number, the equation y equals e to the x. And again, I said it was about 2.72. Now we're going to feed this thing a 0 first, and then a 1. We're just going to do 2 key points. So if we do e to the 0, we would get 1, because anything to the 0th power is 1. It'll take some of y'all so long to figure that out. Blows my mind. And the next one we'll do is e to the first, which would just be e, which is about 2.72. So we're just going to do 2 points. The reason we're not doing 3 points is because unless you have a calculator in front of you, you cannot compute e to the negative first. That would be 1 over 2.72. Pretty small decimal. But anyways, I'm not worried about it. We contain 0, 1, and we contain 1, 2.72. So we're going to go almost to 3. And then we're going to follow that form of the last one that I graphed, because it is an exponential function. It really is ab to the x. It's 1e to the x, so it's kind of ab to the x. Maybe you see that, maybe you don't. That's what it looks like. Domain, left forever, right forever. Domain is negative infinity to infinity. Range gets ridiculously close to 0. You'll see it almost touches that line. Do you remember what we call that line? Think about it. But anyways, it gets close to a y value of 0, and then it rises to infinity as it moves right. The horizontal asymptote that's what that line is, was at y equals 0. All right, there's Euler's number. Next up is a logarithm. Oh, you guys are going to love logarithms. As long as we stay on the pace that I normally do, we'll do logarithms shortly after Christmas break. And it varies from year to year. It depends upon the student body that I have. But it's usually right after Christmas break. One year, years ago, I had such a good group of kids that we actually talked about before Christmas break. That was 15, 16, it's been a minute. Anyways, graph f of x equals log base b of x. Now, I'm not here to tell you what a logarithm is right now, but I will tell you it's the inverse of an exponential. And I'm going to write down a couple of key things here. A log base b of a 1 is a 0, because it's saying some base with an exponent of 0 is 1. A log base b of itself is a 1, because this is saying b to the first is b. Now, when we get to logarithms, these things will make sense. Right now, it's just a bonus. I don't feel like spending 10 minutes of my life explaining a logarithm to you. But if you memorize some things now, it'll make more sense later. It really will. So anyways, we're going to feed this thing two x values. We're going to feed it a 0 and a 1. Sorry. We're going to feed it, I did that backwards. We're going to feed it a 1 and a base. If I feed it a 1, I have an output of a 0. If I feed it a b, or the same base number as is, I have an output of a 1. By the way, these are called logarithms. Logarithms look like the letter R. And your calculators, and even things like Desmos, don't graph these things right. We contain 1, 0, and then we contain some other b, 1. And a logarithm looks like this, and it will cross the x-axis, but it will not cross the y-axis, because the y-axis is something special. The y-axis is what we call a vertical asymptote. And this particular one is at x equals 0, because on the y-axis the x value is 0. All right. Domain and range of our logarithm. This logarithm gets really close to 0 as far as x is concerned, but it never gets there. And it runs right forever to infinity. If you like set builder, all values of x such that x is greater than 0, not greater than or equal to, greater, because there's no equality. The range, it falls forever and it rises forever. And there's a logarithm. I think there's 3 more to go. 2 trig functions and another one that used to be an Algebra II standard, but it's not anymore. In fact, all these used to be Algebra II standards. They're just not. I put the trig on there because the last 4 weeks of your school year, we do trig in here. Trig is not in Tennessee State standards. It's not. But it's important for the next class, not college algebra. Pre-calc. All right, bonus, graph f of x equals sine of x. So this is the sine function. Now, you've done some SOHCAHTOA in geometry, but I don't think you guys had to graph these functions. It's a shame. It's fun stuff. Yeah. All right, let's get started on this thing. Now, if you've watched my unit circle videos, there's stuff in there that would apply to here, but I'm not going to teach you the unit circle in the same video. When we graph trig functions, we don't label these things 0 through 5 or whatever. We use what's called pi rads. So the origin would be 0 pi. I went out to 2 pi because we're going to do 2 cycles, 1 cycle left and 1 cycle right. Halfway between 0 and 2 is 1. Halfway between 0 and 1 is a half. And halfway between 1 and 2 is 3 halves. So I'm using what's called pi rads on the x-axis. Let me just repeat this over here. And at some point in time in this class, you'll be memorizing certain values. you will memorize that the sine of 0 pi is 0. And you will memorize that the sine of pi over 2 is 1. And you will memorize that the sine of pi is 0. And you will memorize that the sine of thrice pi over 2 is -1. And you will memorize that the sine of twice pi is 0. That is one cycle to the right. And the sine, well, actually all the trig functions are what we call periodical or cyclical. But they follow the same things forever and ever and ever. They cycle. And there's 2 full cycles of the sine function. Now, what did I feed this thing? Well, I made the table there. I didn't actually put it there. But I started with a 0 pi. I went to pi over 2. I went to pi. I went to 3 pi over 2. Then I went to twice pi. 0 pi had a y value of 0. Pi over 2 was 1. 0, -1, 0. To draw one full cycle of the sine function, I covered 2 pi. That's the period. Sine and cosine both have a period of twice pi. The domain here, this thing runs left forever, it runs right forever. Its domain is -infinity to positive infinity. Now range on this one's a little bit different. The lowest y value I see is -1. The highest y value I see is 1. So the range is -1 to 1. This one's worth talking about in set builder notation. All values of y such that, let me do that again, -1 less than or equal to y less than or equal to 1, such that y is stuck between -1 and 1. There's the sine function. Next up is the cosine function. They look a lot alike. We use kind of the same gridding here. They're called sine and cosine. They actually differ by a shift of pi over 2 or 90 degrees. And some of the numbers I'm getting, they come from my memorization of the unit circle. And don't worry, I'll make you memorize that thing too. These are all negatives. I forgot my negative symbol. Now, it turns out that the cosine of 0 pi, notice this is the cosine function, turns out that the cosine of 0 pi is 1. Turns out that the cosine of pi over 2 is 0. Turns out that the cosine of pi is -1. The cosine of thrice pi over 2 is 0, and the cosine of 2 pi is 1. So this one's a little bit different in that it starts high, and then it starts falling. Now once you've fallen as far as you can fall, you have to rise again. And again, I mentioned that these things were cyclical. They had a period. They're periodical. So what happens on the right has to happen on the left. And it has to happen for all, I've almost messed up there, it has to happen for all of eternity. Period is still 2 pi. It took twice pi to draw one full cycle. The domain is still -infinity to infinity. And again, my low y value is -1, my high y value is 1, my range is still -1 to 1. And we are ready for the last one. And I am actually ready for this video to be over. We're 44 minutes in. The last one is something that used to be a mother function in Algebra 2. It's not anymore. And I don't really even talk about these kind of things anymore. It's what you call rational functions. And the state of Tennessee pulled out of Algebra 2 because kids were so bad at it. Tennessee Department of Education. Anytime you pull things out to make things easier, you just end up with worse results. Put it back in. Turn Algebra 2 back into the class it's supposed to be, not the class you want it to be. It doesn't matter if you like math or not, it's important. By God, the next generation needs to learn this stuff, or math will fall and crumble too. Maybe that's what you're after. Now, I only do 2 key points on these things. I do -1 and +1. The reason I don't do a 0 is because this is y equals 1 over x. And if I did 1 over 0, I would get undefined. Now, what's actually happening there is what's called a vertical asymptote. You just kind of have to trust me on the shape of this graph. I don't want to spend a whole lot of time working through why it is the way it is. All right, remember this is y equals 1 over x. So if I do y equals 1 over -1, I get a -1 back. And if I do 1 over 1, I get a 1 back. And remember, 0 was undefined. So what's happening here is there is a vertical asymptote at x equals 0. Now, there's actually more than that. There's also a horizontal asymptote on this graph. It actually has an end behavior asymptote too at y equals 0. So I cannot cross the x-axis, nor can I cross the y-axis. And there is my beautiful little graph. All right, so I need to mention 2 other things here. That I did have a vertical asymptote and a horizontal asymptote. The vertical asymptote was x equals 0. The horizontal asymptote was y equals 0. And that'll be on your papers. I just left it off and hadn't caught it yet. Domain, I run left forever, but I can't have an x value of 0. So I write the 0, but I use a parentheses instead of a bracket. And, which is denoted by the letter U, unioned with, I run right forever, starting at 0, but not actually being 0. So there's my domain. The range is exactly the same. Falls forever, rises to a y value very close to 0, unioned with the other side of 0 where it's positive, rising towards infinity. Whew, 47 minutes, 25 seconds now, done. Hope you enjoyed.